Hi, how are you? This is the last session of this unit of astronomy. And today, let's take a quick review of the human exploration in the universe. Okay. For thousands of years, ancient people believed that this is the Earth, right? The Earth is the center of the universe. And the moon, this is the moon, right? The moon. The other planets, for example, this Mercury, this Venus, and the Sun are all moving around the Earth. Okay, and the stars are very far away from us, and they are also moving around us. Okay, so such a belief is called the geocentric model. Okay, geo means the Earth, right? Centric means the center, right? So geocentric model. So this is a belief that believes the Earth is the center of the universe, and the other celestial bodies move around our Earth. Such a model is wrong, right? So now we can abandon such a belief. Okay. About 500 years ago, right? About 500 years ago, Nicholas Copernicus, okay, Nicholas Copernicus, okay, this person, okay, he brought out a new point of view. This new point of view is called heliocentric model. Helio is helio means the sun, right? Okay, heliocentric. Okay, so the sun is in the center. Okay, so this is called the heliocentric model. Okay, so in this model, of course, the sun is in the center, right? And then the other planets are moving around the sun, right? Including our Earth. Okay, this theory is correct, right? Okay, but in this theory, he believed that all orbits are perfect circles, and all speeds are uniform, and it is then this theory is not better than the geometric model. Okay, in predicting the motions of the planets. Okay. This is, of course, this is a scientific revolution, right? Okay, and then a few decades later, okay, Galileo, okay, was the first person who to use a telescope to observe the sky. Okay, so Galileo was among the first few to use a telescope to observe the sky. Actually, he was the first one. Okay, he was the first one to observe the sky with a telescope. Okay, so this is a telescope, and this telescope, he used a few telescopes. Okay, first he used such a telescope in 1609. His telescope, the diameter of the lens is only 1.5 centimeter. Okay, so it is a very small lens, right? Okay, and then later he used a better telescope. The telescope, the lens had a diameter of 3.9 centimeters. Okay, this is the telescope Galileo used. Okay, about 450 years ago, right? His telescope was worse than a $30 toy telescope now on, for example, Amazon. Okay, but in those years, because the in the night, there was no light pollution, right? So we don't forget that he had a much darker night sky views. So there was no light pollution in the ancient skies. So he, with such a bad telescope, he could observe the surface of the moon, the surface of the planets. So his achievements supported the theory of Copernicus, okay, the heliocentric model, right? And then the heliocentric model became the became science. It was not theory anymore. It became science. Okay, it was supported with evidence. Okay, got it right? Today, stargazers still use such telescopes, okay, to get a closer, clearer, and brighter image of stars and planets in the night sky. But this telescope is a refracting telescope. Refracting. You know this word, right? Refraction. What is refraction? Refraction means that light changes its direction in different medium. So, for example, when straight light comes to a lens, then it changes its direction. So, such a lens can converge the light rays. Okay, so a ray of light is converged. Okay, so this is the converging function of a lens. Okay, so this phenomenon is called refraction. Okay, so such lens are called such a telescope with lens, okay, is called a refracting telescope. Got it right? But Sir Isaac Newton, when he was 17 years old, he invented the refracting telescope. Okay, because you know, okay, the lens, the converging lens was a convex lens, can converge the light, right? And you can make a real image with such a convex lens. And you can also use a concave mirror, right? Use a concave mirror to make first to focus light. If the concave mirror can focus light, then you can also make a real image with a concave mirror, right? Okay, so a concave mirror and a convex lens, they have almost the same function, right? They can both converge light, they can focus light, and they can also make a real image. Okay, so the real image appears here, right? It is a inverted smaller image than the object. Okay, but the real image appears here, right? And then you use another piece of convex lens. That is, this lens is called the eyepiece. Okay, this convex lens. Okay, you know convex lens can also be used as a magnifying lens, right? Magnifying, not mirror. Magnifying glass, right? So the magnifying glass. Okay, if you use a magnifying glass, then you see the magnified virtual image, right? Okay, so if you use a eyepiece here, then you can see a magnified virtual image of the real image. Okay, because the real image was here, right? The real image was here. Then you use a magnifying lens to see the real image. So the real image appears to be greater, right? Because this eyepiece is a magnifying lens, magnifying glass. So you see a magnified virtual image of the real image. So the virtual image appears here, right? So it appears to be close to your eyes. So you use a telescope to see an object that is far, far away. The image appears to be very close to your eyes, right? So you can see the objects. You can observe the objects far, far away. Okay, and reflecting. This is a reflecting, right? Invented by Sir Isaac Newton when he was 17 years old. A reflecting telescope has the same function, right? And it has almost the same theory, right? Okay, first the light comes to the primary mirror, which is a concave mirror. Okay, so this concave mirror focuses the light, and then it forms a real image here, right? A inverted smaller real image here, and then after this eyepiece, this eyepiece is a magnifying lens, or say a magnifying glass. So you see the virtual image of this real image, right? But magnified. So the virtual image of the real image is close to your eyes, right? Okay, it is close to your eyes. So you can see things far, far away. Okay, but because this lens cannot be very huge, right? If it is very huge, then it is very heavy. And if it is very heavy, then it changes its shape. So the image is not clear. So a refracting telescope cannot be very large, but a reflecting, this is reflecting, this second, this telescope can be very huge, right? For example, let's see a very huge telescope. Okay, because the concave mirror, right? The concave mirror can be built, okay, on the ground, right? Can be built on the ground, because the concave mirror is not a lens. It's not necessary to see the picture behind the lens, right? Behind the mirror. Okay, it's not necessary. You see the image just in front of this mirror, right? So you can see the mirror. You can see the big mirror here, right? You can see the image here. Okay, because the light is reflected to this focus. Okay. The diameter across this concave mirror is for example a few kilometers. Okay, so this is a very, very huge, right? A very huge telescope. Okay, and you can use for example a digital camera here to see the pictures. Okay, the images of the celestial objects far, far away. Okay, this is the Arecibo, right? Arecibo radio telescope. Okay, it is the largest single radio telescope in the world, and it is situated in a natural valley. Okay, in Puerto Rico. Puerto Rico is part of the USA, right? But far, far away from the continental land of USA. Okay, this is just a colony, a small colony of USA. Okay, Puerto Rico. You can find this place on the map. Okay. Okay. There are many different kinds of telescopes people can use. So this is a telescope, okay, on the mountain. Okay, this telescope uses visible light, right? So you can just use your eyes to see the image of the images of the celestial objects far, far away in the sky. Okay, and you can also use this is a microwave, right? You can use a microwave to observe the sky. So this is a microwave telescope, and you can also use radio waves, right? You can detect the radio waves, and then you see the celestial objects far, far away. So this is a radio wave telescope, right? And people can also detect the X-rays from the space far, far away, right? But a X-ray telescope should be on the orbit above the atmosphere of the Earth. Got it, right? Okay, so this picture says people can use many different kinds of telescopes to observe the celestial objects far, far away in the sky. Okay, and you can also the best telescope is the Hubble Space Telescope. Okay, it is a satellite, right? It is on a orbit around the Earth. Okay, so it is above the atmosphere. So without the disturbance of the atmosphere, it can get very sharp, very clear views of the outer space, right? Okay, let's take a look. This is a picture. This is a picture taken or generated, taken by the Hubble Space Telescope. Okay, see, very clear, right? You can see hundreds of here on one picture. On this one picture, you can see hundreds of what? Hundreds of galaxies, right? Hundreds of galaxies. Okay, millions of light year away. So very far, 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 far away, right? Okay. And you can also build landing machines to go to the celestial objects to see their surface, right? Or even you can dig a hole and see the inside of the celestial objects. For example, the planets, the other planets, right? Okay, so these are landing machines. Okay, and this is a real one. Okay, sent to Mars. Okay, so this is the surface, the ground of Mars. So it appears to be very remote and desolate, right? So it is still not a paradise. It is not a paradise yet. It is still hell, right? It is still hell. So immigration to this place still is not a very good idea yet, right? Okay. So if you want to really experience, okay, or say in passing, actually, to see in passing the views of the other celestial objects, then you can get the true knowledge, right? The truths. Okay, so you can get better truths about the universe. Okay. To send the landing machines to search, or say to arrive at those other celestial planets, then you need to use rockets, right? You need to use rockets to send the machines out into the space. Okay, so this is also technology of humans, right? Okay, and Canada also has its contribution to the exploration of the universe. This is Canada. Okay, this is Canada, right? Canada. But this is arm. Okay, a robot, right? A arm, just a mechanical arm. Okay, so it is called the Canada. Okay, the Canada. What is the use of this machine? This machine can be used to, for example, to repair some components of this, for example, this machine in the outer space, right? So, for example, this one is called the International Space Station. So this is also a machine in the outer space, right? So if a component has some trouble, and then you need to fix it, and then it is dangerous to go there by yourself, so you can use a mechanical arm to do it, right? So that is so the Canada arm can work here. Okay. So this is a International Space Station. Okay. It was launched in 1998, right? And what is the function of this thing? The function is for people to do research here, right? To do research in the in outer space to see if it is different from things on Earth. Okay. So scientists can live here for a few months, right? Scientists can live here for a few months to do experiments to see if really things are different from the surface, from the ground of Earth, or if things are the same. Okay, but you need to do experiment to prove it, right? Okay, so let's take another look at this International Space Station, right? International Space Station. Okay, this is another view. It is splendid, right? Great. Okay. Many countries contributed efforts to the building of this International Space Station. Okay, of course, USA, right? Japan, and Europe. Okay, Russia. Okay, and Canada. Okay, these five parties. Okay, contributed efforts to the building of this facility. Very good, right? Very nice thing. Okay. Scientists can live here. Okay, they can live here for a few months. But after a few months, the scientists or astronauts they can become a little less healthy. Okay. So for example, this person is normal on Earth. So this is A. This picture A is a person on Earth. Okay. A person on Earth. So he looks healthy, right? And then after he has lived in the International Space Station for a few months, and after he has come back home, then his legs become smaller, right? Less muscle. Okay, there is less muscle, weaker muscle, because his legs were not used for a few months, right? So the muscles of the legs become weaker. Okay, so the same person here. This is the same person. Okay, they are the same person. Okay, this is the same person. Okay, under microgravity, or actually this means there is no gravity there, right? So microgravity under such conditions, and this effect is sometimes called the puffy face, third leg look. Okay, and the face is also a little bit different, right? This looks a little bit fatter and weaker, right? less energetic, right? Okay, so a little bit less healthy. Got it, right? Okay, so you and your friend, you can debate, or you can debate with yourself. Okay, write down the pros and cons of the human efforts of the what's it about the exploration in the universe. Okay. Now people are not very rich yet, right? So if we use much of our money to do such space exploration, then it costs much money, right? Every time you launch a rocket, it costs billions of dollars, right? But people are not rich yet, right? Still not rich. There are still many poor people, right? Suffering from disease, hunger, and so on, right? Poverty, and so on. Okay, so this is one thing. So the question is, do you think that people should use more money or less money to do space or say space exploration in the near future? Okay, if you support, you say people should use more money, then 3 reasons. And if you say people should use less money, should save some money, then again you need at least 3 reasons. So please write down the pros and cons of the exploration, okay, in the universe. And this picture, on this picture, what is it? Okay, these are the junk, right? People left behind there, okay, left there in outer space. So the outer space becomes more and more dangerous, right? Okay, for example, if you come to travel here, you can knock onto some of the junk here, right? So now there are more and more junk here. So it may harm our environment, right? May harm our Earth. So you can think of more pros and cons about the exploration. Okay. Okay. So today we just talk so much. Okay. You can do it by yourself. Okay. Write a essay about this debate. Okay. Thank you. Good luck. Have a nice day. Okay. Bye.